Okay. So, so in today's class, we will be discussing about the last topic of the module 2, that is applications of stacks and queues. So till now we have seen what is stack. So we have application of stack is recursion. Next you come with the queues. You have gone with three to four types of queues. So first type is linear queue. Second one is circular queue, third one is double-ended queue, and fourth one is priority queue. So we have gone with the four types. Okay. So now after you learned all these basic concepts, so now we shall go with where they are used. Okay. So you will be understanding the applications. So applications of stacks and queues are today's concept. Okay. So in that applications, now we shall go with contents. So there are only two concepts left in your module 2. So one is mazing problem, and the second one is you can go with multiple stacks and queues. So one is the mazing problem, the other one is multiple stacks and queues. So kindly in these two concepts, mazing problem is very, very important. So keep that one in your mind. I will be giving it as star. So it is very, very important from exam point of view compared to multiple stacks and queues. Okay, but you can easily understand these two concepts. So kindly go through now. So now what is the mazing problem that we will see now? So this is the amazing problem. Okay. So what is the maze means? So inside there is a maze. It is a maze means we are considering it as it is a box. Okay. It is a matrix of box. Okay. Box which is consisting of how many rows and columns? So here we are telling it as it is a square matrix. So square matrix means number of rows and number of columns will be equal. So it is considered as a square matrix, that is number of rows and number of columns are equal. So here it is a square matrix of size 4 cross 4. So 4 rows with 4 columns. So totally how many boxes you will be having? It will be 4 cross 4, that is equal to 16. Okay. So 0th row, first row, second row, third row. Okay. Similarly, 0th column, first column, second column, third column. Okay. 0, 1, 2, 3, 0, 1, 2, 3. Okay. So what is the location of this one? Source. This is the source. You consider there is a rat. Okay. So mazing problem means you have to find the path from source to destination. Okay. But the thing is, you have to move from source to destination, and that is move from only in two directions, that is forward and down. So you should move either forward or you should move either down. There are only two, no back, no coming to previous one. So you are not supposed to get into the previous path. Understood? So what the maze problem will tell you. So you are finding the path from source to destination. So this is the first block, we consider it as source, and the last block we consider it as destination. The source will be considered as maze of 0, 0, and destination will be considered as this is n minus 1 into n minus 1. So how the path is going, and that we will see here. Okay, so here it is a network. Network means you are connecting the source to the destination. So connecting the source to the destination through edges. So this one connecting from this box to this block, we consider it as one edge, and connecting from this block to this block is considered as edges. So one block to another block is connected through edges, and that will mark a path. Okay, so here we are giving it as a maze is given a n cross n binary matrix of blocks. Okay, so maze is a n cross n. As I have already told, it is a square matrix. So square matrix means number of rows and number of columns will be same. So we can take it as n cross n. So n here it is 4 cross 4. Okay. So where source is the upper leftmost block, this is called as a source, that is maze of 0 0. So keep this one in your mind. This is 0th row, 0th column. So zero, this is 0 0, this one is 0 1, 0 2, 0 3. Similarly, you come for here. This is row 1, 1 0, 1 1, 1 2, and 1 3. So similarly, come for this one. So this one we consider it as second 2 0, 2 1, 2 2, and 3 3. Okay. So finally, this one will be considered as 3. So 3 0, 3 1, 3 2, 3 3. So as you consider n as 4 cross 4, so source is at 0 comma 0 and you are ending at 3 comma 3. So how you represent n value is what? N value is 4. Okay, so n value you are considering it as 4, but you are ending it at 3 comma 3. So how you represent in terms of n? So n is equal to 4, but if you want 3 3, you go with maze of n minus 1 into m minus 1. So maze of n minus 1 we consider it as destination. Okay. So now you have to move the rat from source to destination. So rat starts from source to destination and reach the destination. It can only move in two directions. One is forward, the other one is down. Forward means this one. If you are moving from left to right, it is called as a forward direction. If you are moving from top to bottom, it is called as a down. Okay, so it is called as a down direction, and moving from left to right, we call it as what? Forward direction. Okay, so next you come for the next step. So now you have to move the rat. This is the maze. Okay. So inside the maze, you have to move the rat from source to destination by using two directions. One is forward, the other one is down. Okay. So maze is another problem that can be solved using backtracking. So backtracking means if you didn't find the destination, okay, then you can go back to the starting point and you can try. So that we call it as backtracking. So come for example. So this one is source, this one is destination. If you are not reaching the destination, so then you can go back to the source and then you can start from the new path from the source. So read this one. If path does not reach the destination, then backtrack to starting point. Andre, so if the destination ನಿಮ್ಗೆ ಏನಾದರೂ ರೀಚ್ ಆಗಲಿಲ್ಲ, ನಿಮ್ಮ ಪಾತಲ್ಲಿ ಬರ್ತಾ ಡೆಸ್ಟಿನೇಷನ್ ರೀಚ್ ಆಗಲಿಲ್ಲ ಅಂದರೆ ಯು ಕ್ಯಾನ್ ಗೋ ಬ್ಯಾಕ್ ಟು ದ ಸೋರ್ಸ್ ಆ್ಯಂಡ್ ಸ್ಟಾರ್ಟ್ ಫ್ರಮ್ ದ ಡಿಫ್ರೆಂಟ್ ಪಾತ್. Okay, so that is called as a backtracking. So keep that one in your mind, the backtracking concept. So backtracking means if you didn't reach your destination, so you can go back to the starting point and you can start the new path. Start with a new path. Okay, so this is the maze you have given and I have to take the path from source to destination. So from source, so whatever path you consider, it is we are considering it as one. Which block, if you are not visiting any block, that will be considered as 0. So block which you visited will be considered 1 and the block which you are not visiting will be considered as 0. Okay, so if this is the path, now you see, so this one will be marked 1 with 3 zeros and here you are moving from this path, so it will be 1 1 0 0. Okay, this block is there but you are not traveling to that particular block. So if you are not traveling to that particular block, it will be marked as 0. So here also 0 1 1 0 1 0 0 and here you can go with 0 1 1 1. So this is the path. So wherever you travel, that will be considered as 1 and which block you are not traveling, that will be considered as 0. Okay, so this is the, so now you see, so Now you have to consider this example. Okay, so what is the approach and how you are going to solve this amazing problem? So first you form the recursive function. So what is the meaning of recursion? Anyone? So recursion means, so what do you mean by recursion? So you have gone with a recursive, right? So what is the meaning of that? Function called by itself. Okay. So for now, for amazing problem, we are telling we form a recursive function. So when you call a recursive function, can you guess? Recursive means repeated. Okay. So when you go with a repetition in amazing problem, yes, when you repeat, no idea. So see here, I will tell you, recursion means repeat. Okay. Yes, good. So when we can't reach the destination, what will happen? You are going to backtrack. So keep that one in your mind. So when you are not, if you are not finding the destination, so you are going from source to, this is one function call. Okay, you are, if you reach the destination, no recursive call will be there. So if the destination is not reached, then you, what you will do? You will backtrack to the source. So that means you are calling the same function again. So at that time, this backtracking concept, so you are going with a recursive call. Understood? So it will form a recursive function which will allow the path and check if it reaches the destination or not. So if that path does not reach the destination, then backtrack and try other path. So if your path what you have chosen will not reach the destination, then what you will do? You will go back to the source. So you will go back to the source and try another path. So that forms a recursive function. If the destination is not reached, then we go with a backtracking concept. So at that time, we are having a recursive function. So come for the algorithm of that. Okay, so first you create a matrix initially filled with zeros. So here you consider this example. So first row, so don't go for this matrix. First you see the diagram. So first row, second row, third row, this one is fourth and this one is fifth. Okay, totally 5 rows. So how you are going to travel, so that you have to keep in your mind. Okay, so first if you are traveling from like this, you have to remember like this. So first row, which path? So it will be marked 1 year. First initially, all of them will be marked with zeros. Okay. So first step, solution matrix initially filled with zeros. So next you create a recursive function which take initial matrix, output matrix and position of rat of I comma j. So that means you are starting from rat of 0 comma 0. So this one is 1 comma 0. This one is 1 comma 1. This one is 2 comma 1, 2 comma 2, 2 comma 3. So this one is 3 comma, this one is 3 comma 0, 3 comma 1, 3 comma 2, 3 comma 3. And this one you are going with 4 comma 0, 4 comma 1, 4 comma 2, 4 comma 3 and 4 comma 4. So this is the path what we can give it here. So how many rows are there? First row, this one is second row, so this one is third row, this one is fourth row. Keep that one in your mind. First row, so this one is going with second row and this one we are going up to here. So up to here it is third row, fourth row, and this one is fifth row. So which path he is going to travel, that will be giving it as position. Position of rat of I comma j. So first position is 0 comma 0. Okay. If the position is out of the matrix or position is not valid, then return. So if you are out of the matrix, just you return. Okay. So mark the position of output as 1. So when you will mark, when you travel in that particular location, you are marking it as 1. Now you see, you are starting from here, so it is marked as 1. So next you are moving from 2 boxes, so that will be marked as 2. So then you are traveling with 1, 2, 3. So that we consider it as 3 ones. So this one is 1, that's why we give it 1 here, and here it is connecting from 2. So last two are marked as 1 year. So whenever you output position, you have to mark, if you are traveling from that path, you have to mark it as 1. Okay. If the destination is reached, print the matrix. If the destination is not reached, what you will do? If the destination is not reached from the source, so then you have to call the position. So if the destination is not reached, so then you have to start with I plus 1 comma j and I comma j plus 1. So if the destination is reached, no problem. If the destination is not reached, so first you started with I comma j. See here, you started with I comma j. So if it is not reached, then you have to start with I plus 1 comma j. So what is I plus 1? If this part is not reached, then you have to start from this part. So second location. Okay. So unmark the position. So whichever the path you have not gone, so all that path should be marked with 0. So this is up to the mazing problem. So have you understood the maze problem? Understood? Okay, so this will be your attendance link. Kindly fill your attendance here. So next, after the mazing problem, this is up to mazing problem. So next you go with a next concept. So first concept is mazing problem. Second concept is multiple stacks and queues. So now we shall go with a next concept, multiple stacks and queues. So that means inside a single array, you can go with a multiple stacks also. So how you can go with that, we shall see in this particular class. Okay, so an array can be used for multiple stacks and queues, fixing their sizes. Okay, so now first you come with a 2 stacks in a single array. It is only the concept you have. The program is optional. Okay, so 2 stacks in a single array. So when stack of n means maximum elements. So n is maximum elements. So at that time, so when a stack, an array of stack n is used to represent 2 stacks. Okay, say stack A and stack B. Then value of n is such that combined size of both stack A and stack B will never exceed n. So stack of 10 elements. So you can go with n is equal to 10. Okay. So n is equal to 10. Then stack of A. So A will contain 5 elements and stack of B will contain 5 elements. So stack of A will grow from left to right and stack of B will grow from opposite direction, that is from right to left. We can keep the top variable. So this one is top of A and this one is top of B. So because it is a topmost, you are starting with this location means, so first element will go 0, second element at 1, third element at 2, fourth element at 3, and fifth element at 4. So this is called as a topmost element. So similarly, in stack of B, if you are inserting from where? Right to left, opposite direction. First element, second element, third element, fourth element. This will be the top. So the our location 4 will be top of A. So top of A is equal to 4 and top of B is equal to n minus 4. So keep that one in your mind. So this one, the top of A, we consider it as 4, and top of B, we consider it as n minus 1. So this is multiple stacks and multiple stacks. Okay. So now you come for the second one, two queues in a single array. So when you go with a stack, there is only one pointer. So which is that pointer? That is top. Okay. But you come for the queue. So coming for queue, now you have to go with a two pointers. So because the queue will have two pointers, that is front end and the other one is rear end. So multi-queue, multiple queues are maintained or utilized for the process scheduling. So process scheduling that you can understand when you come for the operating system. So operating system means, so your system will be given some process. Okay. So job. So which job will be done? So that one will be, they are used for mild process scheduling. Okay. So how you go for the single array? So here you see. So single array, the two queues. So Q of A and Q of B. So Q of A will be off, that it is ranging from 0 to 4, and similarly Q of B will be ranging from 5 to 9. So totally the queue size is 10 elements. So Q of 0 will point to 0 to 0, 1, 2, 3, 4, and Q of B will point to 5, 6, 7, 8, 9. So front end of 0 and rear end of 0, front end of 1 and rear end of 1. Sorry, it is not 0, it is 1. Okay. So because this is one particular queue, this one is one particular queue. This is the concept of multiple queues in a single array. Okay. So now you have to go with this particular So before going for the problem, now you come for this one. Two queues in a single array. So how you represent two queues? So you have gone with a queue insertion means. So you are NQ. NQ means add an element. DQ means delete an element. Okay. So if you are inserting at the NQ, X is the element that to be inserted in Q. So Q is considered as Qn, and element to be inserted, we have given it as X. So what it will do? Adds an element X to Q number Qn, where Qn is ranging from 0 to K minus 1. So what is this K minus 1? So it will be the range. Okay. So K minus 1, this queue is ending at location 4, and this queue is starting at 5 and it is ending at location 9. So what is the DQ? DQ means delete an element from the queue. So you are going to delete an element from the queue number, that is Qn, which is ranging from 0 to K minus 1. Okay, this is two queues. Now you come for the program. So this is the program that you have to go with queues, two stacks, that is multiple stacks in a single array. So it is an optional, but you can, so it is an optional program you can go through. Okay. So are you able to see this program? Are you able to see this program? Kindly you have to zoom it because it is so lengthier. So you have to zoom that particular thing. So you start from leftmost part. Okay. So I will be just you go with the push and pop operations. So it's more than enough. So you go with a push and pop. So you are going with pushing onto A, popping onto A, and display the QA. Similarly, pushing onto B, popping onto B, and display. Okay. So using these concepts, now you should start. Okay. So while pushing the elements, you have to start from where? So pushing the elements, check for overflow, and then you place an element. Okay, zoom the particular thing. So zoom it. So start with maximum size. I have given it as 10 elements. Okay. So here I will. So I will going to zoom that particular thing. So you can see that. Then I will tell you. While start with the pushing the elements onto stack. So if top of A, so there are two pointers whilst when you go for the thing, top of A and top of B. So top of B will mark the topmost element of the B. So previous one will be the topmost element of A. Okay. So here you can see here. So I will tell you. So this is top of A and this one will be top of B. Okay. So that you have to consider it here. So if this is the last element and top of B will be there here. So you can't insert the element there. So 4 and n minus 4 will be beside to each other. Okay. So now you consider here top of A double equals B minus 1. So B minus, if your top of A is one position to the top of B, then you can't insert. Okay. So that will state it as overflow condition. So what should be done? If it is not there, so what you will do? You will increment the top. Okay, if it first thing is increment the top and move the element to top of A. So if it is not overflow, so what you will do? Increment the top. So what you will do? So you are incrementing the top from location 4 to location 5 and you are going to insert an element. Okay, so similarly pop of A. So if top of A double equals minus 1, there is no elements. If not, what you will do? Take the value and decrement the top. Okay, so take that value, so that is top of A and decrement the top. So when you go for the decrementing of top A, it will delete that particular element. So come for the display. So if top of A double equals minus 1, stack is empty. So if not, you have start with top A and greater than or equal to 0, print all the contents. Okay, so now you come for the push of B. So now you take this one, push of B. So push of B means just you take the same thing. Just you here it is top A is equal to B minus 1. Here it is top B double equals top B minus 1 is equal to top A. So here you have to, there you have to increment. Here you are moving from right to left. So you have to go with a decrement, because if you are inserting an element here, if you are moving from, sorry, so I will take this one. So if you are moving from left to right, increment, you are going for an increment, but it is moving from right to left. So you have to move from right to left. So that means n minus 4 to n minus 5. So coming from 4 to 5, n minus 4 to minus 5, you are going with a decrement. So that's why we go with top B minus is equal to 1 and place an element. So coming for pop of B, so there you are taking it as minus 1. Here you have to go with max. So remaining all things will be same. Okay. So now you come for the main part. So under main, come for the options. Push an element from to stop stack of A, stack of B. Pop an element from stack of A, stack of B, and display the stack A, display stack B. So enter the how many options are there. You are going with the 6 options. So printf, first one is push an element. So push A of val. So second one is push B of val. Take the element and push it onto stack. So pop, if val not equal to 0, then you have to value pop. Okay. So that you are going with a pop function. So similarly, if val not equal to 0, your value popped from stack B. So finally, you are going with the contents. So contents, you give it as display underscore stack A, display underscore stack B. So this is the program for two stacks in a single array. So just I will tell you the things. So if you are going for a push of A, incrementing the pop and place the element. If you are popping an element, place the element and decrement the pop. So similarly, push of B, check for overflow. If not, you have to decrement the pop and place an element. So there it was incrementing the top and placing the element, but here you are going with decrementing the pop and placing the elements. Okay, so next to pop of B, so place an element, increment the top. So incrementing the top, so here it is placing an element, decrementing the top. So that is the concept. Okay, so this is up to multiple stacks and queues operations. So I got you understood this particular concept. So while pushing the element, just you think of first step is incrementing the top and then placing the element. So if you are going with a pop operation, just place an element. So if you are deleting an element, mark the element and then you go with a decrement operation. So that is the concept in push and pop of multiple stacks. So have you got understood? Have you got understood? Okay. Any doubts? So this is up to module 2. So module 2 is completed. Any doubts? Okay. So I will be giving the assignment number 2 of module 2. So kindly submit it after the festival. I will give you 1 week time. Within that, you have to submit the assignment. So assignment will be given, questions will be given by today or tomorrow. Okay. So thank you all.